All right, section 7.5, and this shouldn't take too long. There's basically 4 different things I'm going to talk about. The first 3 are very, very close to each other, so I should be able to do those pretty quick, okay? And we're talking about proportions and all that good stuff. And let's see if this will paste. There it goes. All right, so of course we're going to talk about triangles again. We're talking about similar triangles again. So watch, I'm going to copy and paste, and I'm just going to grab a corner, hit the shift key, make it a little bit smaller. Make it a little bit bigger than that. Okay. All right, so we start off knowing that these triangles are similar to each other. All right, so we do know that. We know the triangles are similar. Now what I'm going to do is I'm going to draw a perpendicular line. So what do we call that? That has a specific name. An altitude. Very good. Okay, that's an altitude. If it's perpendicular, there should be a right angle right there. So I've got 2 similar triangles. I've got an altitude drawn on each of these. Now what I'm going to do is I'm going to label some of these sides. Let's call that A and call this one B. All right, let's call this one C and this one D, E, and F. And just for fun, we'll call this one G, and we'll call this Q. I don't know. I was getting bored with just going in order. Okay. All right, so let's take a look. Here's what the theorem says. And it basically says the same kind of thing for all 3 of these pictures that I'm going to draw. All right. This is the altitude. It says, let me read from the book. It says, if the 2 triangles are similar, the lengths of the corresponding altitudes, that means A and B, right? They're the 2 altitudes, are proportional to the lengths of the corresponding sides of the triangle. They're proportional, which means if you set up a ratio, all those ratios are equal to each other. Agreed? Right? We've been talking about that the last couple of days. So what is the ratio between the 2 altitudes? How would I write that? A to what? A to B. B is the altitude, the 2 altitudes. Okay, this is one altitude and this is the other altitude. So if I compare those 2 altitudes, that's also going to equal the ratios of the corresponding sides. So right, C and D are corresponding to each other. Okay, C and D are correspond. What else? What other sides correspond? E and F. Okay, and G and Q. GQ. How about that? I didn't even think about that. All right, so there we go. That's not too hard to figure out, is it? All right, but the thing is, you got to know which sides are corresponding and all that kind of stuff. Sometimes they'll take this triangle and they'll twist it around and flip it and that kind of stuff. But how do you know which sides are corresponding? You look at the angles that are opposite, right? Does that make sense? So if I made this super easy, just to show you what this theorem says, but I could twist this thing around, I could flip it and all that kind of stuff. But how do you know which sides are corresponding? You look at the sides it's opposite. So this is opposite one arc, this is opposite one arc, so C and D are the ones that go together. Okay, if I put 2 here and 2 here, you know that E and F are the corresponding sides. Make sense?
A and B, because that's kind of a triangle on its own.
The which one?
A and B too. Could that be A and B too?
Well, A and B are both the altitudes, so you know the altitudes go together. All right, so altitude compared to the other altitude. All right, so that's why they go together. So that's your altitude right there. Let's write the word altitude. All right, so that's your altitude, and these are just your corresponding sides. You get it? So the ratio of the altitude equals the ratio of all the corresponding sides of that triangle. All right. Make sense? You got the general idea of this? Yeah. All we're doing now, we're going to do 2 more things. All we're doing now is we're not doing altitude. We're just going to take a triangle and do something else besides the altitude. You remember, I don't know, chapter or 2 ago? Forget when it was. Remember we did altitude. We did what else? Remember we did all that centroid stuff? So we did an altitude, and then what else did we do from a vertex? We did a... Yeah, but not all those words. But what did we do just from this vertex? We did a bisector of the angle. Well, there's a perpendicular. And then, yeah, we're not going to do perpendicular bisector, though, of this one. But we're going to do, yeah, the middle is what? I heard it. What? It's the median, right. It's the median, okay? So we're going to do those. We're going to do angle bisector, and then we're going to do the median, all right? And just for fun, let's pick a different triangle, okay? And let's do another color as well. Quick, what do you want? Ruby. Can you see ruby though?
Oh, make it yellow.
Yeah, mint julep was nice. Mars red?
Yeah.
We'll do that on the next one. Remind me. Okay, look, here's a triangle. And watch. Now, we have to know, first of all, though, that what's true about the two triangles. That they're similar to each other. So you have to know that. All right, so I put a little similar symbol in between them so we know they're similar to each other. So now what we're going to do, I'll tell you what, I'll do this just in a different, oops. Now watch what I'm going to do. I'm going to do an angle bisector. I could have bisected any of these angles I wanted to. It doesn't make a difference. Which one? You want to start down the bottom? The obtuse one? Okay. Now what I'm trying to do is I'm trying to bisect this angle. All right? I'm not necessarily trying to hit the opposite side at the midpoint. I'm taking this angle and I'm bisecting it. And that would look about right in there. Maybe. It's close enough. Okay? Now again, what am I trying to do? I'm trying to bisect this angle. You follow me? So watch, I'm going to copy and paste. Because if I'm remember, those angles would be equal to each other, wouldn't they? If they're similar triangles. So if I bisect that angle, that should be at the same spot. And there we go. Alright, so I've bisected this angle. Let's show it, though. So that angle is equal to this one. Now, in the book, they actually put 2 arcs here and 2 arcs here. But this is the same angle as this, isn't it? So if I bisect the same angle as I do right here, guess what? That's right, they all have 1 arc. Okay, the book puts 2 here, but we can put 1. Now, what's the point of this? Let's call this. Give me some initials.
A.
Alyssa Simmons. Give me another initial.
Taylor.
We can't have an A and an S in it though. Okay, T and H. So that would go over here. Give me another one. M and F. Okay, and let's do this whole one. It can't be any of these other letters that are here. No. J. Who's J?
Joanna.
Jean Lee.
Joanna. We already have an H though.
Jane Lee. Alfred Lee.
Okay, Jane Lee. Okay. And then we'll put an L right there. Okay, good. So we got our letters. That's a lowercase cursive L. Okay. Because an L would look dumb. It would just be that. It would just be a line. So I make it kind of look like it's a letter. All right, come on. Wasting time. Let's pay attention. So what did I do here? These are, I found the angle what? Bisector. Okay, remember there's 3 of these. The first one we did the what? Altitude. The first one we did the altitude. Now we're doing the angle bisector. So let's set up a ratio here. It works the same exact way, except now it's not the altitude, it's an angle bisector. So let's compare the angle bisectors to each other. Let's compare A to what? S. So what do you think that's going to equal then?
MF.
T to H, right? Then M to F, then J to L. And there it is. Didn't I tell you it's very, very similar? Or close to? Use the word similar too much? What we did up there. Alright, let's do another one. And, oops. I copied that. I need a triangle. Let's go back up here. Get a triangle. Okay. Here's a triangle. Let's just kind of...
Make it semi-form.
I don't know, just make it. And... yeah, we'll just use that. It doesn't matter. I mean, this works with any triangle. It doesn't make any difference. Alright. We'll just stick with the white. Okay, so here we go. These triangles are similar to each other. And what did I say we're going to do this time? The median, that's right. So I will actually go to another color. What haven't we done yet?
Purple color.
Didn't you say some kind of red? Mars red? I don't know. Let's see if we Mars. Okay, now what am I looking for? I'm looking for the midpoint of this side right here. So just eyeball it. Where do you think? Right there. Okay? And then if I take this, the midpoint is going to be, it's actually going to be perpendicular if you look into that. Oh, you don't see that Mars red very well, do you? So what did we just show? I showed that that and that are equal to each other, and what else? These two right here are equal to each other. All right, just for the sake of time, let's just do this. A, B, C, D. We'll call this E. That's supposed to be an E. F, G, and H. Okay? So now, look. I can't read that very well. Let's go to
We should do the purple.
Peridot. What in the world's that? Peridot. Never heard of it. Okay, did we do it the other day? So what do we have? Peridot, is that what it is? Okay. It's French. Alright, so here we go. What is it going to be? We take the, what do we call this thing? Let's write it down. What do we call it? The median. Okay, we call it the median. So let's compare it. So E to F, right? This is old now, right? Because we know how to do this stuff. So what is it? E to F is equal to what? A to C, B to D, and G to H. Now, what's the purpose in all this? Well, you know what they're going to do, don't you? They're going to give you some sides. They're going to give you some sides that are missing, right? You got to figure it out. Give me a second, okay? Let me do one more thing. Let's pay attention real quick right here. Okay? Shoot, forgot to give the quiz. We started talking too much.
Because you're talking about Korea.
Okay, we'll do that on Monday. Let me show you real quick. Shh. Guys, Benjamin, stop. Okay? The bell just rang. I'm trying to get this done, and you're messing around. Now look. Watch. This thing right here, what I've done, I'm not comparing two triangles. I'm just looking at this one triangle this time. That's the difference in this than what we did before. This is an angle bisector again.
Would the following
But look,
students please
A,
report to the
B,
library?
C,
Katie Needles,
D.
Kate
Watch.
Kadaka,
If I compare
Alan Day,
A to B,
Lila Stevens,
that's going
Brianna
to equal, what do you
Navarro,
think?
Drea
C
Mathis,
to D. Now
David
look,
Sills,
the A and the C
Emma
go
Sills,
together because they're the ones
Alex
that connect to
Haldeman,
each other. Do you see it?
Ian
The B and the D go
Dale
together because
Gardner,
they're the ones,
Ben
see that?
Gusky,
The B
and Sydney
is on the
Murphy.
bottom, the D is on the bottom. They go together because they connect to each other. So
Would
there's your
Rachel
ratio
Doniger please come to
right
the
there.
office?
Let me give you some
Rachel
problems.
Doniger, please come to the office.
Come on, I let you get away with not doing a quiz. Just go to class, tell them I let you out late. If you really have a problem with it, I'll give you a pass. Okay, she'll yell at you. What are you guys? Okay, here we go. Ready?
Are you serious?
Write this down. Okay, that's it right there.
Wait, 6 to 17.
6 to 17, 20 to 24.